Hello, everybody. Welcome to our most recent webinar with Wells. We're very glad to have you here with us today. My name is Megan, and I'm going to be going over a few housekeeping items before I hand it off to our presenter for today. First of all, Wells is a registered provider with the American Institute of Architects Continuing Education System. This presentation is worth 1 learning unit or 1 credit. If you are an AIA member and gave us your AIA number when you registered, your attendance will automatically be logged through AIA's online dashboard at the end of this webinar. If you're not an AIA member or you need a certificate of completion, those are available upon request. I'm going to go ahead and drop my email in the chat once I'm finished with my portion here. And you can send me an email if you need a certificate of completion, and I'll get that to you within 10 days of your request. So as a registered provider for AIA, Wells does have a few policies, regulations, and rules that AIA sets forth that we need to follow, mostly having to do with the length of the program as well as the length of attendance. If you would like to look at the full listing of these rules and regulations, AIA has them available on their website for you. For questions, you can ask questions about this presentation at any time during the presentation using the Q&A function on Teams, and we will address those questions, or rather our presenter will address those questions at the end of his presentation. But again, you can ask them at any time during the presentation itself. So that's it for me. I will hand it over to our presenter for today, Jace Rosso.
All right, thank you, Megan. As she mentioned, my name is Jace Rosso, and just a quick background about myself. I've been with Wells now for almost 15 years. I started out working in one of our production facilities while I was going to school for a summer job. And then I also interned for a couple summers before starting in a sales role, which I did for about 10 years. And I've been in my current position for the last year as a regional facades manager in the Midwest. So I'm going to turn off my camera here at this point just to not be a distraction. But we'll get started on the presentation here. And just a quick background about Wells before we get into the actual presentation. We did start in the small town called Wells in southern Minnesota, which is where we get the name. And have since expanded from there to be servicing over 30 states currently, all the way from Canada to Mexico. And we started with that 1 production facility, and now we're up to currently at 14. And we're currently working on over 600 projects annually. And these projects range anywhere from a single family garage, the floor of a second level of a garage, all the way up to giant total precast, facilities. And with our 14 manufacturing facilities throughout the country, we're able to really pull resources from each of these different plants, or be able to produce in multiple locations to service some of these larger projects, which can be very advantageous from a schedule standpoint. And 70 years ago when we started, we had about 25 employees. And so now we're all the way up to 2,200 that are able to assist in your project essentially from cradle to grave. We have pre-construction teams, we have project management, we have drafting, engineering. We produce all of our products at our own facilities, and then we install almost all of our projects as well. And so just to give you a current snapshot of, how much we're working on, we're partnering up on just about or over $4 billion worth of projects at this time. And as I mentioned, we're currently up to 14 facilities. Sorry, my clicker's not working here. And one of the major reasons for that is the recent partnership with Gate joining the Wells team. So you can see they kind of take up the southern half of the map shown on here, with traditional Wells being in the northern half. And so by bringing all of us together, again, we're able to service all the way from Canada to Mexico, with the 14 plants scattered throughout this region. And all of our architectural plants are PCI AA certified, which is the highest certification that PCI gives. And that was actually just redone here a few years ago, and there's a few different levels that you can shoot for, and you have to test for it and be qualified. And when that list first came out, it was never a doubt that we were going to be going for the AA certification at all of our facilities, because we are always striving to have the best quality product that we can. And so in that case, it was no different. One of the ways that we're able to achieve this is all of our architectural products are poured indoors. So all the way from, down in Florida up into Minnesota. All of those products are poured indoors in climate controlled environments so that we have the highest quality products. And as we continue to evolve, I'm not sure how much we'll continue to grow geographically, but we're always looking to push the boundaries of the different products and services that we can offer to the market. And so that's what today's presentation is going to be on, essentially the next generation in multi-story construction, starting with the different aesthetic flexibilities that precast concrete, architectural concrete can provide, the schedule and cost benefits of using a single source prefabricated system, the different options that we can provide, not only from an architectural standpoint, but from an overall performance standpoint of the system, and then the reduced environmental impact that using a prefabricated all-in-one enclosure system can provide. So before we get into, exactly how we're planning on doing all of that, let's take a look at how these buildings are currently constructed. So if you look at a multi-story building that is using some kind of a site-built system, it's generally going to be a steel stud cavity wall, exterior sheathing and insulation, and then some kind of an exterior cladding material. And you can see that just looking at that, you're going to have a lot of different subcontractors, a lot of different people, all trying to work in the same area and all having a different responsibility for the enclosure of the building. So some of the issues that can result in is having a cluttered site. You're going to have a lot of laydown areas for all of these materials to be shipped to the site prior to actually being built. You're going to have access to the exterior of the building to install the exterior materials, and not only exterior scaffolding that might be needed, but swing stages, and also in some of our environments that means you're going to have some temp heating as well. So that can really increase your costs as well. And then looking at the schedule standpoint of it, in order to build this type of a system, you generally phase it out so that you're going to have, all of your framing done and then complete the barriers as you go up the building. So it results in a semi-enclosed exterior enclosure throughout the entire length of the project, which can result in a lot of other issues. And so from a schedule standpoint, this is actually a project that we were given the schedule from a contractor. We were looking at a project that was using this type of an exterior system. It was a 25,000 square foot footprint of the building and 8 stories tall. And so the schedule that they provided for us, it'd take 2 weeks to frame the exterior walls, another week to put all the exterior insulation and sheathing on there, and then another week on top of that for all the air and vapor barriers, and then 2 more weeks to install the balconies and window doors. And this is on a per level basis, I should mention here. So you're looking at a total of 6 weeks per floor just to get that enclosed. And so we've kind of always been thinking about it of how can we use our knowledge of exterior enclosure products to find a better way to truly enclose a building faster and cheaper. And so this has been an evolution, I would say, over the last 3 or 4 decades. First iteration of it is just using our traditional architectural insulated precast wall panels as a load-bearing element. You can see the image on the left there of I believe it's a 7-story building. That's all total precast using exterior precast concrete as the architectural feature. But then, when we start to look in other markets and maybe for larger buildings that already have a structural system in place, there's no need to have that structural layer of concrete. So then in that case, we started going with just a thin, solid exterior layer. And then it was, site built again to do an interior furring wall where you ran all the electrical and threw in the insulation and enclosed the building in that way. But one way that we've been able to, still try to expedite that enclosure is by using the pre-glazed panels. So all of these options are still very applicable today for certain projects. But as we were kind of, again, continuously evolving the system, we thought, why not include the insulation back into our panels? And why not have a space for electrical to be run? And why not have the interior of these panels be drywall ready? So we're truly going to be, the entire enclosure and able to turn it over to the other trades immediately afterwards. And then with this system, another factor that we wanted to consider is to make it as lightweight as possible so that it has less impact on the structural system, so that we're able to incorporate it onto, onto multiple structural systems. And so if we go back to, that timing of it takes 6 weeks per level with traditional field built systems, with our unitized building systems such as Infinite Facade, we're able to shave that down to under 2 weeks. And you can see these pictures taken on the left here during installation. So that exterior, the entire architectural facade is included within this system. So there's no need to come back and do additional work to the exterior to really, finalize the look. And on the interior, it's going to be a very clean site because we are including all of any product that's needed for the installation is either included on the panel itself or pre-installed prior to us showing up on site. So you can see not only the time saved, but also the, and the cost associated with that, but then also having that exterior finish done, having an interior that's clean and safe and less congestion on site. And this is, again, just looking at one level. So we're able to save roughly 4 weeks per level. And when you look at that over the entire building, you can see the, the amount of time that's saved on these or by using these systems. And as I mentioned, this has been the result of essentially over 30 years of evolution for this type of a product, using innovation, problem solving, and then collaboration with design teams and contractors to make sure that what we're providing is truly something that will work in the market and is something that is wanted in the market. And then along with that collaboration with those teams, we've also collaborated with other precasters around the country that are servicing different markets so that we can really, tune in on what's working for them and how we can incorporate that into our markets. And so this again is a system that's engineered specifically for multi-story construction. And unlike the multi-trade sourcing that we talked about here a minute ago, we are a single source provider for the design, the manufacturing, and the installation of the entire exterior facade, which is going to reduce the overall risk to the project, not only to the contractor during construction because they're only dealing with one trade for this entire envelope system, but also for the owner after occupancy. If there's any issues, they only have to come find one person. Because we cover all the warranties for everything, they're not looking around at a bunch of different contractors that are trying to find ways that it's not their fault that there's an issue with the exterior. And then this product is going to meet and exceed any kind of energy and code requirements, while again providing the unlimited aesthetic options that come with architectural precast. So that's where we'll begin here, and just kind of a breakdown of the product itself. You can see that we start with the architectural exterior layer, which is going to be a thinner section of concrete than what we traditionally use on projects for this type of project. Next, we are going to include the insulation, and it is a HFO closed cell polyurethane foam with 0 ozone depletion that's also installed at our manufacturing facilities prior to shipping out to the job site. Along with the insulation, we're also going to be installing the windows. So it's a pre-glazed system that is again installed in climate controlled facilities throughout the country. Excuse me. And then on the interior is going to be our HSS steel frame. And this is, we're using this system to ultimately reduce the overall weight. So it's a much lighter weight system than a traditional precast panel. And using the steel frame along with the bearing and lateral connections, we are able to modify it to, to attach to multiple structural systems from total precast, PT, steel, CLT, or even modular systems. So we don't want to limit the project as far as what type of a structural system that can be used on it, knowing that all projects are going to have different requirements. And then after install, we're going to provide all the fire stopping and the smoke barriers at the floor lines, as well as all the panel-to-panel joint sealants. And then on the interior, we have drywall-ready accessories so that you're able to start the other trades soon after we complete our installation. Getting into just an overall look at the system, it is designed to be a horizontal panel that's going to span from grid to grid and go from floor to floor. So you can see just a snapshot of what a typical panel is going to look like with the openings included and the windows included. And you can see that we're able to provide larger window openings and more unique shapes than what we would provide with, with traditional precast or with other prefabricated systems. And just a couple different ways that we can install the windows are shown here, with the top one having some kind of an opaque surface on all 4 sides of the window. And then the image down below is where we actually take that panel joint and move it from the floor line to the head of the window below it, so that you remove that that additional joint between the two windows in a vertical sense. And then the final option shown down below there is essentially a floor to ceiling glass look, where we'll use some type of spandrel glazing at the structural level to hide all of the structural systems. And so you can see how this would look on an overall elevation. The red lines here are shown just to kind of magnify where the panel joint would be. So you can see on the far left and the far right, we're going to have panel joints essentially right at the floor line. And then the middle image is where we take that panel joint and move it to the head of the window below, so that you can get a few different looks, whatever works best for your project. And it's also good to note that you don't have to just choose one of these for the entire project. We can use these different systems in different areas of the building that may require different aesthetic looks. And as we've talked with designers about this, and just different people in the industry, sometimes prefabrication might get a bad look because they say, well, this is all you can do then. You can just you have to have windows all right in a row, all at the same elevation, all in the same location of the panel in order for it to be an efficient use. And so for that, we like to show a few of these projects that we've done in the past. And you can see, just one trend that we seem to be seeing right now is that design teams are looking for a lot of randomness in the exterior openings. And so, especially as the far left image and the right image, that was a lot of work that we did with the design team to, give them the randomness that they're looking for, but do it in a repetitive manner so that it works well with prefabrication. So starting with the image on the far left, you can see, again, we're doing roughly 30-foot long panels here in this project, and then going from floor to floor. And so to break that up a little bit, we used additional reveals, vertical reveals throughout the panel to kind of line up with the windows to give it more of a broken up look. And then in this case, it was as simple as the levels 2 in this application and 4 are the exact same panels. And then levels 3 and 5, we're using a different panel. And so that's just a pretty simple way to give you more of a random look to a building, but to do it in an efficient manner. And then the image on the far right is where, when we first started looking on that, we had roughly 100 different unique panels that were trying to be incorporated into the project. And through collaboration with the design team, we were actually able to limit that down to under 10 unique panels. And again, our intent is to provide the look that you're going for and the overall performance of the building, but to try to do it in the most efficient way from a fabrication standpoint. And then the image in the middle there is more of kind of a multi-level architectural vertical look to the exterior. So that's still a horizontal panel, but at every other level, we just used a different architectural mix to make it look like that window frame continued down through. So utilizing all of these different options for window layouts, you're able to give a unique look. But then on top of that, we get a lot of requests for some variation in the exterior skin. And part of this kind of started from a little bit of a challenge or collaboration that we did with a local architect here, as far as what are the different features that you're looking for in these types of projects that generally become, either too costly or take too long to do out of site-built systems. And so the renderings on the left there kind of show what we got back. And so we took those images and we panelized them and we made mock-ups to kind of prove our concepts. And so you can see that, again, there's a lot of articulation in the skin. And when you're trying to do that with a site-built system, you picture a 10-story building or whatever it may be, and you're trying to do all these unique features in multiple areas around the footprint, but then also on every level. And so you're going to have to build that detail, 100 times or 1,000 times, whatever the size of the building may be. Where with a prefabricated precast concrete option, we're able to build that form once, make that detail one time, and then pour over it 100 times. And so you can see how you're saving on the efficiency you gain there, I guess, from only having to produce that detail essentially one time and then pouring over it multiple times. And then along with the articulation, we've seen a lot of requests for multiple finishes within a panel or within different areas of the building. So each of these options, basically, well, I should say the 3 on the right essentially are using multiple mix designs or incorporating cast-in thin brick to the panel or using some kind of a stain application. So the different options that we can provide from an architectural standpoint are wider than any other product on the market, I'd say. And starting with the image on the far left there, which is our just a traditional architectural mix using a water wash, an acid etch, and a sandblast finish. This is a very cost-effective way to get different textures and different tones of color on the building but again, using one mix design and just different finish applications to give you that different look. Next to that, the thin brick, which is where we use a true brick, a clay brick material that's just thinner, hence the name thin brick. And that we actually cast directly into the panel. So it's not like, I think the first iterations of this type of a product was to do the lick and stick on the exterior, and there was problems with those brick falling off over time. These brick are truly cast directly into the concrete of the panel, creating a very solid exterior surface that we don't have any issues with in the future. And then below that image is terracotta, which we've worked on a couple projects in the past as well, incorporating that to the exterior. The top middle picture there is our polish finish, which is essentially how you would polish a floor, but we do it on our panels. So that when you stand it up and it's on a vertical surface, when the sun hits that, you really get that kind of extra shimmer to the panel, which can create some pretty cool exterior looks. Below that image is a logo essentially that we use at our CNC machines that we have at all of our facilities. So we're able to essentially create any unique design that you want to incorporate into the panel, whether it is truly a wolf or a husky, whatever that is on the side of your building. Otherwise, using that CNC machine to make different shapes or different reveal patterns, that type of thing, to again give a customized look to the project. But if we can't complete what you're looking for with our reveal patterns or special shapes, there's also form liners that can be incorporated. And really the amount of form liners that can be used today is pretty limitless. You have your traditional stone form liner shown there on the bottom, or we've seen a few more requests recently for wood form liners up on top, or modern form liners such as the basket weave shown on the far right there. So all of these are finishes and features that we've been providing for decades, and can be incorporated into any of our wall panel systems. A couple more that I just want to highlight here is we've been seeing a lot of requests, again, for multiple materials to be included on the exterior facade. And a couple of those materials are stone and metal panel. And so we can cast stone directly into our wall panels, similar to how we would do a thin brick. We just, put it down in the bed, pour the concrete over it, and it's bonded directly, or not directly to it. There is a barrier for expansion and contraction, but it is part of the panel as we ship it to the site. Or we can use a metal panel, which can be, again, installed after production, installed onto the face of our panels in a rain screen application. And these are both very viable options, but they can become cost prohibitive at times. So we have a couple other options, which is our simulated finishes. So you can see the stone on the bottom left there. That is just an architectural precast mix, and we use a process that creates a pitted or a textured exterior feel. And then also it gives it a little bit of a color variation. So it gives a much more natural look to the concrete. So it looks like a natural stone. And that can be done with essentially any color that we can do with our traditional architectural product offerings. And then the image on the bottom right there is our simulated metal panel finish. And this is a penetrating chemically bonded stain. So we carry warranties on that as far as, if it chips, the stain is penetrated into the concrete itself. So if it chips off, you're still seeing that same color. It's not like an exterior paint. And then because it's chemically bonded, we also carry a warranty on any kind of fading. So you can see these different finishes used in a real world application. So the image on the left there of the architectural concrete, but I would bet that most people would not be able to tell that that is actually concrete and not stone. And then the image on the right is a project that we recently completed where we were adding onto a building that was covered in metal panel. So that's the top three images there is the real metal panel that was on the building. And then the bottom three images is our panels after they had been stained with the simulated metal panel. And again, vast majority of people aren't going to be able to tell that these, that's a different finish, that's not metal panel. And so by using these finishes, you get the look of a real stone or the look of a metal panel, but you get it with the durability of concrete and at a much lower cost point. And so all of these finishes that we've talked about here can be incorporated into the same project again. So whether that's, the middle image there where you're using a couple different form liners, a couple different mix designs all within the same panel, or the image on the left where you have multiple architectural mixes and different finishes and reveal patterns within each of those finishes, but they're all essentially done on separate panels so that it's, again, a more efficient way to do it, but also gives you a lot of different looks to the building. And then the image on the far right there where you're essentially incorporating all of these practices into one total exterior facade. And sometimes, as you're trying to incorporate all of these different looks and finishes, it may make sense to just use a different material. We understand that. We're not trying to force you to use our system everywhere, because this is truly a cladding system. We're able to integrate it well with other materials. In this case, it made sense. There's a lot of areas where there's just a lot of glass that was needed for the project. So we just stopped the infinite facade in those locations, and the other trades were able to take over from there to incorporate the glass. And then same with the first level, they were looking for a lot of field laid stone, and so they were able to incorporate that as well. And then we worked with them to make sure that the transitions between the two materials was covered. So now that we've kind of talked about, essentially the architectural features and what the building would look like from the outside, we'll kind of dive into what it's going to look like, or how the product and the building is all brought together. So it starts with our production at our manufacturing facilities, which are, again, all of these products would be poured indoors where it's always sunny and 70. So you don't have to worry about having low quality concrete or any curing issues. The spray foam that's installed, you don't have to worry about, the expansion rate that would be completed, at different temperatures. It's always done at the same. So you're getting, again, the highest quality exterior look, the highest quality insulation, and that you're getting a consistent depth with that. And then the interior frames that are shown here, the HSS frames, those are protected as well so that they aren't at any kind of a risk to the elements when they're stored outside, but they are produced right in with our panels on the interior, and again can be adjusted to fit any type of a structural system or any type of a window layout that we had already previously discussed. And then you can also see here the hat channels for the drywall are pre-installed within our facility, so that again it's ready for the next trades when we show up on site. But after production and prior to shipping to the site, we got to install all the windows. So the window systems that we can use with this, again, can be with any window manufacturer. The only thing that we're looking for is that it is attached to the steel structure on the interior of our panel. So we're not using some type of a residential window is the word I was looking for there. Residential window that's attached to the exterior of the concrete. This is clipped back to our structural system for a couple of reasons. One, the architectural layer of concrete is purely architectural. There's no structural capacity to it. So we get it back into the steel frame so that it's securely attached. And then also that gives you access to it in the future. If for some reason you needed to change out a window, you can just peel back the drywall and you have all the attachments right there. And like I mentioned, we can work with any window manufacturer, so we're not limited on the color or the size. We can use fixed, we can use operable, we can use louvered, we can incorporate metal panels into some of these window frames as well, so that we're giving you the look and the function that you need for any given project. And like I mentioned, these are all installed in factory controlled conditions, and they're all at eye level. So that's a huge one. There's not additional equipment that's required to install these, and there's not the amount of site congestion that this would take up if all these windows were installed on site, from an equipment standpoint, from a delivery standpoint, from a getting windows up to these upper level standpoint. It's all done ahead of time and then shipped to the job site already pre-installed. And prior to sealing or to shipping, we're going to seal all of the windows as well. So we seal the interior and the exterior of these windows. So you can kind of see on the far right there what the window detail would look like prior to shipping out to the job site. And then once we're on the job site, a lot of times these projects are going to be in areas that have pretty tight sites. So we've worked with, using tower cranes. We've used our own cranes in these sites. And really the way that we're able to reduce the overall disruption on the site can't be overstated, because if you look at especially the image on the bottom there, bottom left, this is in an area where they only had one lane closed essentially on all. Basically, if you look at all four sides of the building, there's only one side that had a lane closure, which is shown here in the image. And so we just took up this one little corner in the bottom right, backed our trucks in there. And we especially designed trucks that, because this is a lighter weight system, we're able to get up to four panels on a load. And so that, first of all, reduces the overall number of loads that are coming to the site, which reduces costs, which reduces, carbon emissions. And then also just reduces the overall site congestion. So because we're able to bring in 4 or 8 or 12 or however many we need at a time, and we can actually drop the panels there, or drop the trucks there, I should say, and have kind of a continuous loop in that manner. And so there's a lot less trucks coming into the site and the issues that you have to deal with trying to get a large semi into a downtown area. And we can reduce the amount of lane closures that are required, and just the traffic disruptions as well. And then talking again about the tower cranes and the light, or a crawler crane or whatever crane it may be, with the lightweight nature of these panels, we're often able to reduce the overall size of the crane required. So if you look at a traditional precast panel, there may be an instance where we actually have to reduce the size of the panel in order to accommodate the crane, which reduces the size of the panel, creates more panels, which creates more swings. And so with this lightweight system, we're able to essentially have more square foot per swing for that exterior facade. And then since we ship these vertically, there's no need for an additional crane on site to just trip the panels, which can be required with some systems. So that is a way that we really, I guess, make the site a lot more efficient from that standpoint and have less disruption. And then as we're setting the panels, you can see that again, it's an entire enclosure, an entire exterior facade that's all going up at once. The windows are pre-installed, so there's nothing coming to the site from that standpoint. And then on the inside, it's going to be a very clean and efficient set. If you look at just the amount of labor that's required to set these panels on site, we have a few guys down by the trucks. We have a few people up on the decks actually installing the panels. And that's essentially it. So we're generally running with a much, much smaller crew than what you would see on site for any other type of site-built system. And then again, the interior finish as we're installing is going to be much less disruptive. These pictures were taken right during construction. None of this was staged. You can see again, just a few people installing the panels, some people welding, and then after we're done, we clear out everything that we have in the area, which is very limited to begin with, and leave a nice clean site so that we're able to start doing our field installed sealants. And so from the exterior, we're going to do a 2-stage joint sealant at all of the panel-to-panel joints, and then at all of the horizontal floors, we're going to provide fire stopping and smoke barriers, as you can see kind of on the far right there. And then once we're done sealing from the exterior and at the floor lines, we come back and do all of our touch-up spray foaming. So we're going to spray foam the back of the vertical joints, the horizontal joints at the floor lines, and then any other areas that were needed to be blocked out for any number of reasons, so that we're truly giving you, full enclosure of insulation, edge to edge, floor to floor of all of our panels. And then once we're done with that, we're able to turn it over to the other trades, and you can see the electrical can be attached directly to the drywall hat channels that we've already previously installed. So the electricians attach the boxes right to those channels and then run the conduit, within the cavity of the hat channels and within the cavity of the wall panels. So it's, again, easy to turn over. Next, talking a little bit about how we can provide our enclosure knowledge to assist in the overall making the project a success. And so we want to be able to assist you in any manner at any step of the project. So obviously, when you're working on your conceptual designs, we can help you out with some preliminary modeling or preliminary, architectural exterior options, panel sizing options, window options, getting into the schematic design, just talking through those details a little bit more, starting to pick out some architectural colors, and then into the design development where We can help finalize with some of your details that you may be working through, whether it's with the our product itself or integration with the other materials. We're there to help. And then finally, with the construction documents, providing our shop drawings that we do all of our projects in Revit, so we can provide a model directly to you that you can either use for just as a view, or you can incorporate that directly into your drawings as well to help expedite that process. And so, we understand that how we're going to be helpful and how we're going to be the most valuable to you is going to vary from project to project. And so we like to, we pride ourselves on being a true asset to the project, not a liability. And that, is going to have multiple paths to success. So if you're looking at your project, no matter, I guess, what part of the project you are, owner, developer, architect, contractor, engineer, at some point you're probably going to be looking at a model similar to this and deciding how do we get to the next steps from here. And so traditional delivery methods are going to include, the preliminary drawings, and then you move on from that phase into the detailed drawings, with your budgeting and everything, and then finally come to a point where you bid out the project, and then you would do the shop drawings and move into construction. And so this is a system obviously that has worked for a long time, but one of the drawbacks to this is you're not truly establishing your cost until after that bid there. And so that can result in, redesign that may be required to get the project back within budget. And you can kind of get caught up in a cycle there at times. And so it just creates more of a headache in a lot of ways. So one thing that we like to provide as well is more of a true design assist delivery method, where we can work with you from preliminary drawings, essentially what we have shown here in this model. We can get you some pretty accurate pricing and panel information just based off some limited information, your overall massing, your footprint size, your floor to floor, window to wall ratios, information like that. We can get some pretty solid cost established at that point, and then work with you as you're going through your detailed drawings. We're also doing our shop drawings at that time. We're meeting with you in order to make sure that essentially what we originally agreed on, we're continuing through that process, and maybe enhancing some of the architectural features, or if we need to find ways to reduce costs a little bit, we can work with you directly during that time, to complete that process at that time, I should say, instead of trying to get to a point and then starting over. So you can see the time saved that is potential for using this type of an approach to a building. But again, we know that's not going to happen on all projects, such as this one, where this went through a couple different contractors that couldn't quite make the budgets work. So it was over budget, and we were eventually brought on to help find a way to panelize this and to make it a prefabricated system and to get the cost back in line, and for the exterior system of the building. And so you can see, the original design incorporated 2 different bricks, some metal panels, some fiber cement board, some traditional precast in some areas. And so we started taking a look at this, and then again, using our full array of options that we can provide for architectural features, we're able to not only incorporate them, but also panelize this entire exterior facade in a way that makes sense from a prefabrication standpoint. So you can see, again, using 2 different architectural mix designs within different panels, incorporating the 2 different types of brick, and then there will be some field applied stain for this project as well. But we're able to take the image on the far left and able to panelize it, incorporate our finishes, and in the end, create an exterior that looks very similar to the original intent of the project. And lastly, I just want to talk a little bit about, sustainable construction and the overall environmental impact that, using prefabricated systems can help provide to the project. And when we look at sustainability in construction, I like to kind of break it down into 2 parts. There's the materials that you're choosing to build the project and what the environmental impact is for each of those materials. So as far as, getting the resources out of the ground or wherever it may come from, and getting them to the site. And then what is the environmental impact and the sustainability of the project once it's complete and throughout its life cycle. And so in kind of looking at both of those options, or both sides of sustainability, we like to be as transparent as possible. So we have all of our precast products have EPDs that we share on our website. It's available to anyone to go look for. If you have any more questions about any kind of sustainability issues, you can reach out to us. And we're always trying to, get better and better from a sustainability standpoint. And with a concrete based system, the biggest factor is going to be the amount of cement within the exterior system or within the product itself. So we're looking at ways to reduce the amount of cement. One of the things we did a few years ago is we switched to a cement that used a higher limestone content. So there is less true cement within our cement. And then we're also looking at ways to, use fly ash instead of cement, where that works out in our products. And we're also looking at trying to create thinner cross sections and then just reduce the overall amount of cement that's required within our mixes. Obviously still needing to meet any kind of structural capacity requirements. But on the thinner section standpoint, you can see, the traditional precast wall panel will have anywhere from, 6 to 9 to whatever the design requirement might be for the amount of concrete within a cross section of a panel. With this system, we're actually only using roughly 2.5 inches of concrete in order to create that exterior facade. And then, starting to move on to the sustainability of the building after construction, we use that full edge-to-edge spray foam insulation, so we can meet, any R value that's required for the different regions. But first and foremost, we're going to have a 2-inch solid layer of insulation, continuous insulation between the exterior concrete and the steel frame. So we're getting that continuous insulation requirement there, and then filling into the cavity whatever the additional requirement might be from an overall R value standpoint. And so to kind of test this out, we just looked at a comparison quickly of a project in Minnesota using a 40% window to wall ratio. And we plugged in, the ASHRAE standards. We plugged in, number one, there is a curtain wall system. Number two is a metal panel exterior, similar to the one that we talked about at the beginning, site build system. And then 3 and 4 are just two different versions of infinite facade using 3 inches of insulation and 4 inches of insulation. And, not to dig too far into this, but really you can see that the lower that green line, the lower those bar graphs, the more efficient the project or the exterior system is. So the more efficient it is, the less overall operating costs, the less energy usage, the less environmental impact. So you can see that this system is really helping in a lot of different ways from a sustainability standpoint. And also, we've talked a little bit about meeting code and performance requirements. We wanted to make sure that we didn't have any issues from that standpoint with our system. So before we really even brought it fully to market, we did a lot of testing on this. So you can see just a quick snapshot of some of the different tests that we performed on this panel system. And we also wanted to make sure that we were using, essentially what we did is we used a worst case scenario for all of these different tests. So for example, the top right one there is a water intrusion test. And so our sealants are shown there in the light purple color. So they really stood out, and we made the joints extra wide. And so just as a way to fully prove the system and make sure that we're not going to have any issues once we actually get within our own tolerances on the project. And then the image on the the bottom right is the fire test that we did, and we used a thin cross section, thinner than what we would normally use for our architectural concrete. And again, all of these tests passed with flying colors, so we know that when we get in within our actual tolerances, that we're going to be above and beyond any kind of performance requirements for the project. And you can see in the middle there, we actually have our own UL system number based on the different tests that we performed. And so you, I guess, can incorporate that directly into your building science portfolio. So in summary, the Infinite Facade is a complete building envelope solution that meets or exceeds energy and code requirements with optimized performance and flexible aesthetic options that we've talked about here today. And unlike traditional multi-trade sourcing, it's delivered with a single source provider. So you have less issues with finger pointing or anything like that, and is going to reduce the overall risk, not only again during construction, but also to the owner after construction is complete. And it's going to accelerate the occupancy of the building because of how much time we can save with just the exterior envelope, which is going to turn this building into an income earning asset for the owner faster than other materials. So with that, I thank everyone for joining us here today, and I'm gonna pop up to see if we have any questions.
Thanks, Jace. We are on a little bit of a time lag from when you present and when our attendees actually see the presentation. So it might take
Okay.
a few seconds for the questions to start coming in. And I just wanted to take this moment while we wait for the questions to remind everybody, or those of you who may have joined our presentation after I did my little continuing education spiel, that if you do need a certificate of completion, you can go ahead and send me an email. I did put that in the published Q&A, so you can find it there. So just send the request for the certificate to me, and I'll get it to you within 10 days of your request. So.
Okay, and I do see one question came in here. Do you need to drop the entire building with a swing stage to seal your panel-to-panel joints? And that's really going to depend on the building itself. You know, we've done some projects that maybe aren't as tall where we're able to, and we have access to the entire perimeter, where we're able to do everything from some type of a lift. But then there are applications where maybe the building is just too tall to reach safely with a lift, or we don't have access around it that we can use the lift. So it's something that we're always, you know, looking into ahead of time and making sure that we're coordinating with the contractor so that we can do it, you know, efficiently and on time. Next question, going back to the installation slide, it shows a trailer with 4 panels on it. How long would it typically take to install the 4 panels? How many trailers can be installed on a day and on average? And that again is going to depend. There's times where we can install many panels within a night, or a day, I should say. And on that note, I mentioned night because one of the projects that we're working on right now, we had a lot of the time where we did that as second shift. So that's not an issue for us. We come out, you know, especially for a project that's got a PT structure where they need the crane, the tower crane all day long. And so we're able to just wait until after they're done. And then we come out and we have essentially full access to the site, and we can set panels and, you know, in a much cleaner and more efficient way. Next question is a good one. What is the average weight per square foot of your system? Again, that's going to depend. I don't want to say that as an answer to every question here, but it usually does depend on what that exterior looks like. So if we have just a flat panel, for example, you know, and we don't have a lot of projections or build out or skin articulation, we're going to be roughly 35 pounds a square foot. And that again is also going to depend on the window sizes, but that's just kind of a good starting point. And then any projections or anything like that on top of that would just obviously add to that exterior weight. Question was, what is the latest phase a project can be in to begin discussions? Understand ideally to be brought in early, but for worst case planning. And another good question, which is why I kind of wanted to talk about both sides of how we look at that design assist there. And your second half to your question there kind of pointed out that, yeah, it's great if we can get in there early and we can kind of help as the project is, you know, initially being designed. But there are also times where we've been brought in afterwards. You know, the project that I referenced there, where there was a lot of budget problems with it, and we were able to come in afterwards and able to save money by using a prefabricated system. You know, we also got to factor in with the contractor and the architect when it gets to that point is what is the redraw time that might be required. So that's again just something to factor in. But I would say it's never too late. We're always willing to jump in and help you as much as we can to provide any options that we can. Next question there, how much tolerance can you build into your system? And there, you know, I'm assuming that's in regards to, like, for example, if you look at a steel structure or PT structure, they're going to have different levels of tolerance as far as, you know, the floor to floor heights and the amount of movement in their deck and everything. And we can include enough tolerance in there to meet any kind of standard tolerances that are already in place for those other systems. So that's, we kind of leave it up to that, and we make sure that our tolerances will meet whatever may happen on the project itself. What are common metal framing sizes, and does it require a separate structural engineer to do that design? So again, all of our panels are just a cladding, but the structural component to our panels themselves are the HSS frame, and we design that all in-house. We have our own engineers that run the design calcs on on the frame itself to make sure to meet any kind of lateral loading requirements. So no additional engineer required for that. And then the thickness of the frame, again, will depend on the type of system, depending on where we can get bearing points and all of that. But generally, it's going to be either 4 inches thick for that steel frame or 6 inches thick. So overall, that means that, we have, say, 4 inches of a steel structure, 2 inches of insulation, and 2.5 inches of exterior concrete, or roughly 8.5 or 10.5 inches of the system itself, plus the 1.5 thick hat channel on the interior. And that goes into the next question, I guess, of the average total thickness of the concrete. That concrete itself is generally going to be 2.5 inches thick at a minimum, and then any kind of projections to the exterior skin is going to go out away from that. So in most cases, it's 2.5 plus projections. How is the exterior concrete layer connected to the HSS frame? That's going to be through pins that are going through the spray foaming. So typical, or similar to a typical sandwich wall panel that you'd use for concrete, where you have, pins going between the insulation to connect the two whites of concrete. We're using the same technique essentially by having pins go between the structural frame to the architectural layer. And so there's another question just kind of about set rates, and for this presentation, I don't want to get too deep into that. If you have further questions, you can reach out to me directly here. All of my information's on the screen, and we can kind of talk through your project and what we would be looking for, or looking at from an overall install time frame. And are each window water tested at the facility, or are they water tested after erected on the structure? And there again, we're gonna, kind of work with the contractor, work with the building science people as far as what's required. Is it, do we need to do a water test at the site or at our plant? We can do that. Do we need to do it on site? That we can arrange for as well. So it's really just an overall collaborative effort to see what's going to be required for each individual project. How is your structural HSS frame typically attached to, say, a PT or precast building structure? And that's going to be with kind of, those bearing points that we talked about a little bit at the beginning, where we essentially will have some type of a steel plate embedded into our panel that will be either embedded into the concrete structure or attached to the steel frame that we're connecting with, generally a welded connection as the final connection to the building. How do you mitigate delamination of the spray foam on the backside of the panels? I've seen this as a problem in the past from a result of bouncing during transportation, as well as moisture driven from the concrete itself. So we do testing at our facilities, pull tests of the insulation from the exterior layer of concrete to see if there is any kind of an issue that we may have with that. From there, we haven't seen any issues in the past where that insulation is going to delaminate after that point. Because again, just one thing to consider as well is when we produce these panels versus when we ship them, generally there's a lot of time where they're sitting in our yards. So that concrete is fully cured out. So if there were going to be any kind of issues, it would happen at our plant. How long does the panel connection take from the time that panel is hanging in place to when the hook is released? That again, I'll save for an offline conversation if you want to reach out to me to talk a little bit more about that and how our actual process works. But again, it is going to be a very quick install as compared to any other type of a system. Any other questions? Okay. Well, I guess I'd just like to thank everybody again for jumping on here and spending an hour with us today. Hopefully you learned a lot. And if you have any more questions, you can follow the QR code on the screen or reach out to me with my information provided there as well. And we look forward to working with you on your upcoming project.